Okay, this is section 5.1, part 2. And a lot of the problems you're going to have today will deal with factoring trig functions. And so we're going to quickly review some factoring from Algebra 2. Okay, so if I look at A, if you'll notice, and if you remember, this is the difference of squares. This is something squared, x. 1 is something squared, which would be 1, and it's subtraction, so that's the difference of squares. And I factor the difference of squares of x as x minus 1, x plus 1. Or I could do it the other way around, x plus 1, x minus 1. Okay, and that's the answer to that. This one, I wrote this down wrong. This should say x squared minus x minus 2. So if you'll fix that, x squared minus x minus 2. All right, so when I'm factoring a trinomial, I'm going to have two sets of parentheses. I know my first terms will be x and x. I know my signs will be different. And I know my largest number will have a negative next to it. So I need factors of 2 that when I subtract them I get 1. So that's going to be 2 and 1. So 2 and 1. My signs are different and the minus sign has to go with my 2. Okay. Part C. And first, as I'm doing this, I should always check and make sure I can't factor anything out, that they don't have a common factor. And none of these have had one so far. So on C, I'm going to have my two sets of parentheses. This time it's a 4x, so it could be 2x and 2x or 4x and 1x. This one's not too bad. I would factor this as 4x and x. And then factors of 3 are 3 and 1, so I have to figure out where my 3 and 1 would be. So my 3 is going to be here, plus 1. So 4x minus 3x plus 1. And if you don't remember how to factor things with a coefficient in front, we'll go over that in class. We'll do some more examples. I teach it several different ways, and so we can go over that again if we need to. In part D, if you'll notice in part D, I have an x in common to both of them. So the first thing I'm going to do is factor out an x and write down what I have left. My first term, I'd have a y squared left minus, when I factor this x out, you can't put 0 there. You're going to put a 1 because when I distribute back, I would have to get my original problem. And so when I distribute x times y squared, x squared minus x. Now if you'll notice, this is the difference of squares. So I can go ahead and factor that, y minus 1, y plus 1. Okay, so we did that just so you can have a reminder of factoring. So here's what they're going to do is instead of having just normal problems like this, you're going to have problems like this. Secant squared theta minus 1. Well, if you'll look, this is the difference of squares. This is something squared, secant. This is something squared, 1. So I would factor this secant theta minus 1, secant theta plus 1. Okay, and then that's your answer. Now, when you have a problem like B, do you notice that I don't have the same trig function throughout the problem? I have a cosecant squared here and a cotangent here. So I need to change this in order to factor it to where it's the same trig function. So the first thing I notice is I have something squared here. I have a cosecant squared x. So I automatically look at my Pythagorean trig identities to see if I can rewrite that using a cotangent. So looking at your Pythagorean trig identities, cosecant squared x is equal to 1 plus cotangent squared x. And that's good. That's going to help me out. Okay, so I'm going to replace this cosecant squared x with what it's equal to, which is 1 plus cotangent squared x. So I just replaced that part. I still have a minus cotangent x minus 3. Now I'm going to combine like terms. I can combine this 1 with this negative 3. So now I would have cotangent squared x minus cotangent x minus 2. And if you look back at the first problems that we have, this is this problem, x squared minus x minus 2. But instead of x's, I have cotangents. See, x squared minus x minus 2. So I can factor this. I know cotangent x will be my first term. I know my signs are different. My factors of 2 are 1 and 2. And my negative has to go with the 2. So that's how I would factor that. Cotangent x minus 2 times cotangent x plus 1. Okay, let's do 2 more. Okay, if you'll notice, this is just like this problem that we did. 4x squared plus x minus 3, but instead of x's, they use tangents. All right, so I can't factor anything out. This is going to factor just like my other one. 4 tangent theta, and then tangent theta. Okay, and then my minus 3 and plus 1. All right, so let's look at part D. Part D, I have something in common. I can factor out a sine x because this has a sine x, this has a sine x. So I have sine x, and I'm going to write down what I have left. Cosine squared x minus 1. Now there's two ways you could look at this problem. This is the difference of squares. Okay, I could factor it that way. But another way I could write this, if and the directions on this would say either factor or simplify, I automatically notice that this is really close to Pythagorean identity. All right, it's only off. It should be 1 minus cosine squared theta equals sine squared. So what's wrong with it? It's perfectly fine except for the signs. Do you see that? So what I'm going to do is I'm going to factor out a negative from this inside part. If I factor out a negative, I'm just going to put it in front of the sine x. And now I'm going to write down what I would have when I factor out that negative. It would be negative cosine squared x plus 1. Well, now this is this. So I can rewrite this whole thing as sine squared x. So now I have negative sine x times sine squared x. And when I multiply sine x times sine squared x, I get negative sine cubed x. And that's my answer. Okay, we are going to do examples 1 and 2 in class together tomorrow. You can go ahead and start on part of your assignment, but the ones that you get to that says rewrite so that it's not in fractional form or use the substitution, you'll have to wait until we do these 2 examples together.